Welcome to page 6 for grade 7 advanced material post-course test. We are still working through our 7th grade material. These are things that you should be proficient at. Not all things have been covered in your 7th grade school year, but maybe it was covered in 6th grade. Maybe it's going to be covered in 8th grade. Maybe you just didn't get enough time to master it when it was introduced. So these are really good opportunities to check in, see what you know, fill in the gaps, and address things that you may have forgotten. So number 72, you want to estimate the number of students in your school who support extra funding for the music club. You survey every 6th student who enters the school. Determine whether the sample is biased or unbiased. I'm going to say that it's unbiased. And the reason why it's unbiased is because you are getting a random group of students. You're getting first graders, kindergartners, 8th graders. You're not privy to just people who like music. If you were querying people from coming out of music class, then it's going to be biased. So this is actually an unbiased because you're getting a very good random sampling of your student body because they're coming through the school, and it's every 6th student. You asked 200 randomly chosen students to name their favorite ice cream flavor. Of the students you asked, 49 said vanilla, 59 said chocolate, 56 said strawberry, and 36 said chocolate chip. There are 1,800 students in the school. Estimate the number of students in the school whose favorite ice cream flavor is chocolate. So we're going to write an equivalent fraction, and we're going to do chocolate over students. So we have 59 there. We have to add out, there's 200 that were asked. And then if there are 1,800 total students in the student body, we want to know if this percentage, applying this percentage to this group of students, this was to 200 students, it's going to be 1,800. So it should be what we call proportional. So one way that we can solve this is we can do cross product. We can multiply these two and these two. It's a nice way of doing it. We could also 200 times what equals 1,800. We also could have multiplied it by 9, and that's another way. So option 1 is cross product. Option 2 is proportional because this is a factor of 1,800. So I'm going to do the proportional one because I'm just going to multiply 59 times 9. 45, 53, so 531 students favorite ice cream was chocolate. Chocolate. Okay, so that's a nice way of doing it. Either way is good. The dot plots show 2 data sets. Express the difference in the measures of center of data set A and data set B as a multiple of the measures of variation. Well, we see that it's similar shape, right? And that it's just been shifted over from 30 to 20. So as a multiple, the variation is the mean. What's MAD? MAD is measures, I forget, mean. What is MAD in statistics? Sorry. Let me take a peek. MAD in statistics is, what is it? Measures mean absolute deviation. Okay, so how do we find the mean absolute deviation? It's the sum of the difference. Yes, what do we do? Mean absolute is the measure of statistical calculates the average distance between each data point and the mean of the data set. Okay, so we got to do a little math here. So if the mean, because these are balanced, is going to be mean of data set A, the mean is going to be 60. And each one, we're going to take the average of each piece. So technically, I think it's going to be 60, right? So that's going to be 30, 20, right? So we do 30 plus 20 plus 10, right? Is it the absolute distance? I think, yeah, 10 3 times. And then that's going to be 0, and that's going to be 10 3 times. And that's going to be 20, and that's going to be 30. Right? I think it was the absolute value. Let's go. Whoop, where'd my, oh, well, history, mad, absolute value, yeah. Okay, so that's good. So the sum of those divided by the number of numbers. So the sum of those divided by, we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16 pieces of data. So let's add all that's 50, 60, 70, 80, 90, 100, 160. 160 divided by 16 gives me 10 is my mean data. So, and express the difference in measures of center of data. And then if we do this, I would assume that we're going to get 10 too. So, I mean, it says the mean is 1 times the mad. The difference in the means is 1 times the mad. Yeah, well, I mean, it's going to be, yeah, okay, 10. Yeah, I mean, that's 10. This is going to be 10 away. Mad is going to be mean data set. And then this is going to be the same thing because your mean of data set B is going to be 50. And then that's going to be 30, 20, 10, 10, 10, zeros, 10, 10, 10, 20, 30. And we're going to get the same number because there's 16 points. So that's going to be 10 also. Our mad hit there is going to be 10. So I don't know. That's an interesting one. But the answer says 1 times mad. So, right, if that equals 10 also, how many times? Yeah, well, 10 times 1 is 10. So I guess that's how they do it. That's a good one. The table shows random samples of the ages of viewers of 2 different movies. Describe the shapes of the distributions of the viewer ages for each movie. Okay, so movie A, we're going to have to find the smallness. So let's put these in order. So 22 is the least number here. So movie A starts with 22, then 23. Is there any other 23s? There's a 24 and a 24. 24, 24. There's a 25, 2, 3, 4, 4 25s, 2, 3, 4. How many did I say? 1, 2, 3, 4. 1, 2, 3, 4. 26. 1, 2, 3, 4. 4 26s. 27. 1, 2, 3, 4, 5, 6. Yikes. 1, 2, 3, 4, 5, 6. We're running out of space real quick. 28. 1, 2, 3, 4. 28, 2, 3, 2, 3, 4. Let's move you over. And 29, 1, 2, 3, 4, 4 29s. 1, 2, 3, 4. No 130, 2 30s, 2, and 31, and 32. 31, 32. So there's 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6. There are 30 total numbers. So describe the shape of the distribution of the viewer ages. So, okay, so now we would do this. We'd do it. So that's 22, 23, 24, 25, 26, 27, 28, 29, 30, 31, 32. So there's 122, there's 123, there's 1, 2, 24s, 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4, 5, 6, 1, 2, 3, 4, 5, 6, 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4, 2 30s, a 31, and a 32. Okay, so that's sort of shaping towards 27. Our mass is sort of between 25 and 29. Good. So now let's do movie B. Let's take this, let's group it so we don't lose it. Let's group. Let's make it a little bit smaller. Let's move it down so we can do movie B. Okay. Now movie B, let's again put them in order because that really made it easy to keep track of it. So 40, 38, 37, anything below 37, 36. So there's a 36. There's 137. There's a 38. 2 38s. 39. 139, 2, 3, 4 39s. 1, 2, 3, 4 39s. 41, 2, 3, 4, 4 40s. 3, 4, 41, 1, 2, 3, 4, 5, 6 41s. 1, 2, 3, 4, 5, 6. Guess I could have just listed these. 1, 2, 3, 4, 4 42s. 2, 3, 3, 4 43s. 1, 2, 3, 4. 2, 3, 4. This is very inefficient. I should just list them and have the numbers next to it. Sorry. If I could do it again, I'd do it that way. 44, 1, 2, 2 44s. 45, 145. 146, 1. 146. Thought I saw 2. And 146. Okay. Let's do our dot thing. So we start at 36. 36. 37. 2 38s. 1, 2, 3, 4 39s. 1, 2, 3, 4. 1, 2, 3, 4 40s. 1, 2, 3, 4. 3, 4, 5, 6 41s. 1, 2, 3, 4, 5, 6. 4 42s. 1, 2, 3, 4. 4 43s. 1, 2, 3, 4. 2 44s. 1, 2, a 45, and a 46. All right, so there it's like 41. This one's 27. So the question says, describe the shapes of the distribution of the viewer. Well, movie A, shape is to 27. Movie A trends to 27 years old. And movie B trends towards 41 years old. Yeah, so A is much younger than movie B. The table shows random samples. Find the appropriate measures of center and variation for each distribution. Sorry. Yeah, so this, and they're symmetrical. You see that there's some symmetry there. So the shapes, distribution, the shapes. So they're symmetrical. They're both symmetrical. You've got fat tails out there. You've got the mass of the majority of your values in here. Sorry. So find the appropriate measures. We can do the mean. So here we could go back to here and we can add all these up and find the average of them, which I would assume is going to be about 27 and 41. You can use the median. You can use the mode. So the mode is going to be, so movie A mode is going to be, what do we say, 27. Movie B mode is going to be 41. Those are pretty consistent about where that mean is going to be. The mean is 27. The mean is going to be 41 also. So that's good. Compare the age of viewers of the two. Well, we know that, so movie A is younger crowd. Movie B is older, middle age. We'll say older to middle age. We don't want to say 41 is old, but middle-aged. Okay, find the circumference of a circle with a radius of 8 kilometers. Use 3.14 or 22/7 for pi. So circumference of a circle is, and we're given the radius, so we would use 2 pi r. You could also use pi d, but that's when you're given the diameter. Since we're given the radius, we will use radius. It's 8, so we'll use 3.14 times the radius, which is 8. When would we use 22/7? When the radius is a multiple of 7. Since 8 is not a multiple of 7, we're going to use 3.14. So we have 16 times 3.14. And 3.14 times 16, we'll do the math. 2. 6 times 1 is 6 plus 2 is 8. 6 times 3 is 18. Take a place, and let's erase this. And we have 1 times 4 is 4. 1 times 1 is 1. 1 times 3 is 3. We have 4. We have 12. We have 10. We have 5 with 2 decimal places. So the circumference is going to be 50.24 kilometers. It is a distance, so it is 1 degree, 1 dimension, so that's why it's just kilometers. So 50.24 kilometers. Find the area of a circle. Area is pi r squared. There is no diameter one. It's only with radius. So it gives us the diameter we have to find. Diameter equals 2 radius. Okay, so if 2 of the radius equals 1 diameter, we're going to divide 26 by 2 and get 13 equals our radius. And pi, we're going to again use 3.14 because 13 is not a multiple of 7. So we do 13 squared. A equals 3.14. I think that's 169. 13 squared. Come on. Come on, calculator. Oh, see. 13 squared equals 169. 169, and then we have to multiply that by times 3.14 gives us 530.66. 530.66. Doesn't tell us to round, and our units is inches, and it's going to be inches squared because this is inches squared. This is going to be inches. So 13 inches times 13 inches is 169 inches squared. Times 3.1 would give us 530.66 inches squared. Don't forget the units. Can you construct a triangle with side lengths 1 meter, 7 meters, and 8 meters? No, you cannot. So the longest side is going to be your hypotenuse, and the sum of your sides cannot equal. You can't have 1 and 7 and then this be 8 because even if you took 7 and then 1, that would equal your, so that would never be able, even if it was open 180 degrees, that would be 8. So your sum of your other two sides must be greater than? I'm pretty sure. I'm going to say no. Yeah. No, it has to be yeah, I'm pretty sure. Side lengths and hypotenuse. Let's just see what that rule is. Let's type it in. It's always good. Side length and hypotenuse. And a not right triangle, so maybe not hypotenuse. Side lengths of triangles rule. Yes. The sum of the lengths of any two sides must be greater than the length of the third side. So, yeah. Okay, so it's any two sides must be greater than. Okay, so let's take that and copy that in here because that is really good to know that rule. Whoops. Okay, must be. So if we take any two sides must be greater than, these two are greater than that. These two are greater than that. These two are greater than that, but these two are not greater than the third. So that's why it's no. Oh, and that's it. Okay, another good, quick video. Keep working on that. That MAD is very interesting. So take some time to learn that part.